In this video, we'll learn about how to calculate the monthly payments and the balances of adjustable rate mortgages. We'll do two examples. Let's begin with the first one with a simple ARM loan without payment cap or interest cap. In this example, we get an adjustable rate loan for $60,000. The loan will mature in 30 years. The year one's interest rate is 10%. Now we know that the interest rate of this loan would adjust every year based on the index. In year two, the annual interest rate is 12%. Okay, now let's calculate the payments and balance. Let's begin with year one. So the calculation of year one's monthly payment is identical to the calculation of calculating the monthly payment of a fixed rate mortgage for 10% annual rate. So we know that the number of payments is 360 for 30 years. The monthly interest is 10 divided by 12%. The present value, which is the loan amount, is $60,000. The loan fully amortized. By the way, if I do not, or the question do not say the loan has remaining balance, then we assume that the loan fully amortized. Then the future value is 0. We punch the numbers in your calculator. We know that year one's monthly payment is $526.54. So let's calculate the balance of this loan at the end of year one. So we use a future value approach in this case. We know that we have been making payments for 12 months. So we know that by the time we get this loan, the value, the present value today at time 0 is $60,000. We know that in the next 12 months, we will be paying this amount 12 times. And the interest rate is, in that year, is 10 divided by 12. So we know that the PV of the 12 payments plus the balance after 12 months is $60,000. So in the calculator, we calculate the future value that make those two, the 13 payments actually, right? 12 monthly and the 1 balance at the end of month 12. So the present value of all those payments should equal to the PV, which is the loan amount. You enter the number into your calculator, you should get a future value of $59,666.47. So now we know the end of year one balance is also the beginning of year two balance. So how to calculate the monthly payment in year two? In year two, you're pretending you're calculating the monthly payment for a fixed rate mortgage for 12% per year for 29 years. So the number of months of payments remaining is 348. We know the beginning of year two payment is equal to the end of year one payment, which is calculated from the previous step, is $59,666.47. So we enter those numbers in your calculator. You know that with the new interest rate, the monthly payment is $615.97. So when the interest rate increased from 10% to 12%, your monthly payment also increased from $526 to $615. And similarly, you should use the same approach, the future value approach, to calculate the balance of the mortgage at the end of year 2. Okay, next, let's look at a more complicated calculation with payment caps. We have the same loan for $60,000, 30 years, and the interest rate in year 1 is 9%. And the interest rate would change every year, and the margin is 2%. This margin is being added to the index. So we know that the year 2's index is 10%. So we know that the interest rate we pay in year 2 should be margin plus index, which is 12%. And in this problem, we have a payment cap. This is basically saying from previous year to this year, no matter how much the interest rate change, the payment can increase by 7.5% at most. What does that say is if the payment is with a new interest rate is higher than that, you would only be required to pay for the capped amount. Let's see how that is calculated. So the question is the same as the previous problem. First, we want to calculate the payments in year 1 and year 2. And then we will be calculating the balance at the end of year 1 and year 2 with the payment cap. So we know how to calculate the monthly payment in year 1. And year 1's ending balance is the same as year 1's ending balance calculation in the previous practice problem. You use the future value approach. So next, you want to calculate the monthly payment in year 2 without a cap. So from the previous step, we know that the end of year 1 balance is $59,590 at the end of year 1. This is also the beginning of year 2 balance. You pretend that you get a mortgage for 29 years. Okay. So the mortgage also say it can only increase by at most 7.5%. So the maximum payment the bank can ask from you in the second year would be, with a cap, is $518.98. So you compare the maximum payment with the new payment ignoring the cap. We see that the capped amount is less than the amount you should pay without the cap. So this would be the monthly payment in year 2. So the cap actually worked. Next, let's see how that payment, the cap payment, affect the year 2 ending balance. So your approach is pretty simple. We use the future value approach. We know that the N is 12, right? So you're standing at the beginning of year 2. So you know that 12 months later, you would be making this payment, $518.98, 12 times. You know the loan amount at the beginning of year 2 is $59,590. The interest rate in year 2 is not affected by the cap, so it's still 12% per year, which is 1% per month. We calculate the future value. The future value is $60,565.63. So this is beginning of year balance. This is end of year balance. You compare the beginning of year balance with the end of year balance, you see that the amount you owe the bank actually increased. This is called a negative amortization. How did that happen? It happened because your unpaid monthly payment, from $615 to $518 is almost $100. So this amount, $518, is not even enough to pay for the interest. So not only the principal was not being reduced for the year, the unpaid interest is also being rolled over to the balance of the loan. So although you've been making positive payments, your loan size grew. That is adjustable rate mortgage with negative amortization.